Hello everyone. So today we will be learning the concept of RAID architecture, which is the redundant array of independent disk. So what is a RAID? So basically it has two terms. We call it as either an independent disk or we can call it as an inexpensive disk. Because in very simple terms we can say that it's like a collection of or an array of hard drives. It can either be HDD or SSD, or it can be a combinations of HDD and SSD. So the main focus of by using this architecture is like how reliable it is, like how the way that we are going to store the data very efficiently, and the way that we are going to access the data, and how it is how it's keeping the copies of data, so that the data loss, how it is going to manage the data loss. So it depends upon the rate level also, because every rate technologies doesn't have the concept of that the storage of a copy, but maximum levels of RAID is having. That is why we are studying the different levels of a RAID. So each level, like when it comes to RAID 0, RAID 1, RAID 2, its features will get changes. So that is the simple concept that I can say about RAID. So as I said before, the from the term itself you will get the exact definition. So redundant means it's like a, it will maintain the backup of the data, because for us data is very important. So it's like when something happens to a one drive, we will be able to access the data from another drive. Then, as I said before, this is an array. So it's like a collection of hard drives. So it is, we are not talking about a single drive here. So there will be multiple drives will be there. Then comes the independent. So as I said before, one drive is independent to each other. Now let's see the types of rate levels. So first one is that we need to be like before going for the rate levels, first we need to know what is the some points, some components related to rate. So it comes up like what is stripping, mirroring, and what is parity. So these are the main three components that we need to know before we learn the concept of the types of reads. So stripping is the process of splitting the data into blocks. So blocks means, I believe you guys will be knowing what is a block. So here we will be going to divide the data into certain blocks. It will be of fixed size. It's like a small location that we can say. So because we are not storing the whole data into that particular storage location, we are going to split the data into a chunks. So we call it as a blocks. So here in rate level concept, we are dividing the data into block levels. Now it's not like each block is having containing the entire data. No, it will be dividing, the data is being divided. Then second component is the mirroring. So mirroring means we are going to store the copy of data, which means whatever information that I'm going to store in one drive, the exact thing will get stored into another drive. Then last one is the parity. So parity is like it's like a separate drive, which means suppose I'm having four drives, and including parity, just consider parity is another drive. So in total I'm having five drives. So what is this fifth drive will do is, it will calculate an XOR operation, which means it's like, again it's like a you know uh, it will store whatever data is there in drive 1, drive 2, drive 3, and drive 4. It will calculate all the XOR operations of this data, and it will get stored into the fifth drive, which is my parity drive. So whatever happens, like suppose if because whatever data that we are storing, it will be like a combination. Because suppose the word document is split into two, so drive 1 contains the first half, drive 2 contains the second half. So if something happens will drive 1 means parity, that parity drive already calculated the XOR operation, so it will be able to retrieve the data. So we can see with the help of an example. Now let's just go through what is a rate level 0. So when we simply when we say, it's like combination, a collection of drive. So it's very simple, like here we are going to divide the data into certain blocks, and we are storing all these data into a fixed set of a data, and we are storing into different drives. So as I said before, this particular figure, see, this is a this particular thing is one drive, this is second drive, so total I'm having five drives. But here the thing is that we are not storing a copy anywhere. So when one particular drive will get when something happens to my drive 1, then I won't be able to retrieve the data. So that is one of the disadvantage. But the thing is that storage utilization is much more convenient in RAID level 0. This is a basic RAID level actually. So here we are not maintaining any backup of the data. Here the thing is we will be able to get a lot of hard drives, but the thing is that we won't be able to get a backup. So this is the advantages and disadvantages as I said before. Then comes the RAID level 1. So RAID level 1 uses the concept of mirroring. As you know the concept of mirroring, which means here we are maintaining a copy of data. So data loss won't be happening. So here see total 4 drives I'm having. So whatever I'm storing in the drive 1, the same copy is exactly, it will get copied into this particular drive, which is my third drive. Sorry, this second drive. So similarly, whatever data that I'm getting stored in the third drive, it will the same exact copy, it will get stored into the fourth drive. So data loss will not be happening. So accessing the data here, the one point that you need to be very much careful, accessing of the data is much more easier, but writing the data, it will take bit time. Because why I'm saying it is taking a lot of time, because whenever I'm storing the data in the drive 1, the exact copy I need to maintain in the second drive also, which is a time taking process. So that is one of the another thing that we need to be consider of. Then comes the RAID level 3. So RAID level 3 is like the same concept, but the thing is that some differences there. Here instead of splitting the data into the block level, we are splitting the data into byte level. Okay, so you know what is a byte. So one byte is like 8 bits. So it's like a very small unit of data compared to that of a block level. So very much small unit of the data we are storing in a particular location. So it's like a we need a huge space for that, and also it is having a dedicated parity. So this particular level uses the concept of parity. So the parity is that, see this particular figure. So I having 4 drives, and this is my parity drive. Okay, this is a dedicated parity. So see this A1, A2, A3 and A4. Suppose these 4 datas are related to each other. Suppose I have a Word document. I splitted this Word document. So some of the informations are in A1, the remaining is in A2, A3 and A4. So what happens if A1, this particular drive will get lost or fails? So this parity, what is do is it will calculate the XOR operations, which means the A1 XOR, A2 XOR, A3 XOR and A4 XOR. So whatever XOR operations it is doing, the data is getting stored into the parity drive. So whatever, if something happens to this particular drive, I have a parity drive here. So I know the XOR operations. So definitely I will be able to retrieve the data very easily. So that is another advantage of by using this particular RAID level 3. So error checking is one of the advantage of the dedicated parity. So these are the again the disadvantage is that, like, every time we are updating the data, we need to update the parity also. That is another time taking process. And yeah, that's all about RAID level 3. Then RAID level 4 is the only difference between RAID level 3 and RAID level 4 is RAID level 4 is we are dividing the data into block level, and same thing, it is having a dedicated parity. So here the thing is much more we won't be able to save a lot of space for it, because we are dividing the data in the terms of blocks. Now then comes the RAID level 5. So RAID level 5, again we are going to divide the data into block level, but the thing is that here we are using distributed parity. So it's like, here we have a parity here. It's like not a dedicated parity. Here we are not using dedicated parity. In before example it was a dedicated parity, but here we are not using the concept of dedicated parity. So the parities will be distributed. So if something happens to the particular data, easily we will be able to retrieve the data with the help of a parity drive. Then comes the RAID level 6. So RAID level 6 is like a dual parity. So if more than a one disk, like if suppose 3 disk will become fails, means we will be easily able to retrieve the data. So that is another advantage of using the dual parity. So this is the advantages and disadvantages of RAID level 6. So the difference is that RAID level 5, it uses a distributed parity. So it will improve the read performance, but again the write performance is getting the a bit time taking process. So here the thing is that even though I'm distributing the data, if something happens to one disk or more than one disk, that is a disadvantage because we XOR operations, no. But in the case of RAID level 6, it is using dual parity. So if more than one or two disk fails, that won't become a problem. So RAID level 6 is overcoming the disadvantages of RAID level 5. So this is the the introductory concept of the whatever RAID levels that we have discussed. So yeah, that's the concept of RAID and why are we using the RAID and its types of RAID levels and its advantages and disadvantages. So hope you understand the basic concept of the RAID levels. So thank you so much guys for your time.